Hello, I welcome you all to this wonderful lesson. So it is a continuation from where we ended last time. So I just want you to follow me clearly and attentively. One thing that I've observed so far is that some of you, like a question that is like this, you just want to answer it without considering an equation, which is a chemical equation. So if you look at the way this question is, what mass of magnesium oxide, what mass of what magnesium oxide will be produced when 0.5 moles of magnesium burns in oxygen? So here, when you look at this question, when you try to analyze it, you discover that they are talking about a product, something that is being produced. For a product to be formed, it means that we need to have reactants. So for you to answer this particular question, you need to form an equation, which is a chemical equation. But I observed that some of you were just going direct. Okay, mass, you just say mass is equal to number of moles times molar mass. This is what some of you were doing. You are not supposed to do this. You only get to do this if they have only mentioned one compound which is not produced or which is not reacting. They are just telling you to say, okay, what mass of magnesium oxide is there in blah blah blah, like that. But whenever they are considering two reactants reacting together, it means that you need to form an equation. So don't make that mistake again. So what mass of magnesium oxide will be produced? So we want to find the mass of magnesium oxide. What we are going to do, we know that when a substance burns in oxygen, that type of an equation is called a combustion reaction. I want you to get this. So sometimes they may even ask you, don't say, we didn't cover this. Whenever a substance burns in oxygen, that type of a reaction is called a combustion reaction. But when oxygen is added to a substance, we get to call that as an oxidation reaction. These two are very important. They look similar. This one is where a substance is burning in oxygen. This is where oxygen is being added to a substance. This is a simple understanding that I want you to get. So here we are talking about magnesium like this, plus burning in oxygen. Oxygen gets to exist as the atomic atom, which is giving us what? Magnesium oxide. This is a chemical equation. How do we balance this? There is 2 here. We put a 2 there. We also put a 2 there. This is what I need to do. So once I put a 2 there, I put a 2 there. So meaning this is now what? This is now balanced. This is now what we get to call a balanced equation. It is now balanced. Magnesium 2, magnesium 2. Oxygen 2. This 2 is also covering for oxygen. So this is a balanced equation. After doing something like this, what you are supposed to do, what you need to consider now is this. You are going to say, I want to find mass when given the number of moles. So this is mole to mass calculation, because we are taught to find mass when given number of moles. So we are going to compare this. We say they want us to find the mass of magnesium oxide. So I'm going to say, okay, this side, how many moles are here? How many moles are this side? I say, okay, how many moles? I'm going to use this ratio. Have you seen? This is 2. So I'm going to say 2 what? 2 moles of magnesium equivalent to what? So 2 moles of magnesium equivalent to what? I calculate now the mass for this one. So what is the mass? Magnesium oxide, which is like this. This is our magnesium oxide. If you do this, I guess we all know how to do this. This is 1 times 16. This is 1 times 24. 4. This is O-level periodic table. So what is 16 plus 24? You are going to get what? You are going to get 40. So we say 40 what? 40 grams of what? This is 40 grams of magnesium oxide. But because there is a 2 here, we need to consider the balanced equation. So we multiply this one by 2. We are going to get what? 80. We say 80 what? 80 grams of magnesium oxide. Have you seen? And then when 0.5 moles of magnesium, I now say 0.5 moles of what? Magnesium. Equivalent to what? I put X there. So I want us to answer these things together. We need to answer this particular question together. Hope you've understood this part. Here, these 2 moles, that's a 2. From a balanced equation, if there was a 1, I would have said 1. Then this one, the molar mass for this one is 40. 40 grams per mole. Since we want to find the mass, we just say grams. Then there is a 2. We multiply this one by 2. So this is mole to grams. Mole to mass calculation. This is what you are supposed to do. You now find this value of X. So X times 2, that is 2X, is equal to. Then I say 0.5 times 80 is just the same as 40. This is 40. When you multiply there, you are going to get 40. Then you say over 2, even there over 2. This cancelled. You are going to have X, which will be equal to what? Which will be equal to 20. So I will say 20 what? 20 grams, because I want to find grams. These two, you can cancel them like that. So 20 what? 20 grams of magnesium oxide. So this is how we get to calculate questions. The same way I've answered, this is how you are supposed to calculate. Just like this is how you are supposed to answer a question. So I want you to hear me very well. So this was just the division. This is what we covered last time. So I just wanted to catch up with you people. Let us now go to what we are supposed to look at today. So what we are supposed to look at is what we are calling mass to mass calculation. Mass to what? Mass to mass calculation. So mass to mass calculations now. Mass to mass calculations. So mass to mass calculations, this is where you are given the mass, you are told to find the mass. This is what I mean mass to mass calculation. So this is something that is so simple. We are just building on concepts. So if you understood or if you've understand what I'm just from sharing, it means that this part that I'm just introducing will be very simple to you. So then how can we find such questions in an exam? How can you know that, okay, a question will be like this? And even as we are covering these things, the key point here is to understand the concept. Make sure you understand what I am teaching here. That's the main thing. You understand. Because, for example, if you find a question that what is mass, you are not supposed to tell me that I didn't give you the definition for mass. You just need to know what mass is. Mass is what? Mass is the amount of, we say, amount of matter contained in a substance, or the quantity of matter in a substance. That is mass. So mass is just the quantity of matter in a substance. You don't need to say, okay, the sun never told us this like that. No, there are certain questions that you just need to know. Like the one that I gave you, where I will say, what is the use for this and that? You just need to know those parts. So for example, you are given a question. Let's say you are given a question to say, calculate. This is a question you are given. They're telling you to say, calculate the mass. So I want you to be writing. Even as I'm writing, you are writing. That's why I'm moving that slow. So that I also give you chance to be writing. Calculate the mass of calcium chloride. So I want you to calculate the mass of calcium chloride produced. So calculate the what? Calculate the mass of calcium chloride produced when 40 grams of calcium carbonate of what? Of calcium carbonate reacts with hydrochloric acid. So when it reacts with the hydrochloric acid, this is a question that is given. So how can you know this? The way this question is, you cannot answer it direct. So I want you people to, I know certain people are even doing some calculations, you are answering, you are writing a lot of things. A question that is like this, unless if you know what you are doing and if you know that you've mastered this skill, that's when you can now calculate direct, because you are going to consider an equation in your mind and you now calculate. So if you are an expert in these things, I can understand you can do. But the same way I'm answering, this is the easiest way to answer these things. So you don't even need to panic. The same way I'm answering, that's how you are supposed to answer. So calculate the mass. Calculate the what? The mass. When given mass. So this is mass to mass. You are taught to calculate the number, or you are taught to calculate the mass, to find mass when given the mass. So the first thing you need to do, you get this equation. Calcium carbonate reacts with hydrochloric acid. So calcium carbonate is like this. This is how calcium carbonate is. This is calcium carbonate reacting with hydrochloric acids. We are going to have three products because of a carbonate that is there. So meaning we are going to produce a salt that is calcium chloride plus, so when this, then we are going to have this one that is here. This is what? This is hydrogen. When hydrogen reacts with one atom that is from carbonate, which is oxygen, it produces water plus, then you say carbon dioxide. So you may tell me to say, sir, me, I cannot know that I'm going to have three products. This is the reason why I'm teaching you. So whenever you see calcium carbonate, it can be, here you can find magnesium carbonate plus hydrochloric acid. It is just one and the same. So you know that, okay, I'm going to have three products. So you don't need to know that, okay, when this reacts with that, what is going to be produced is this. No. What you just need to know is the concept, what I'm teaching you. So you know that, okay, this is, so you can have magnesium. When you have magnesium carbonate is going to be like this. When it reacts with this one, which is hydrochloric acid, what we are going to produce inside is magnesium chloride plus what? Water plus carbon dioxide. This is what you are going to produce. So don't write this. I just want to connect concepts so that you try to understand, because some of you like saying, equations, I have issues with equations. These are simple things. Just know, okay, you marry concepts. So there's so hard to give a question like this. So when this reacts with this, what is going to be produced inside? There is a salt that is produced here. So we've not yet started looking at salts, but I remember I gave you a definition for salt. So you should also know that definition of a salt. We've not yet started, but you need to know that a salt is a compound formed when the hydrogen ion of an acid are fully or partially replaced by a metal or ammonium. So the key thing is getting the concept. Then you say, okay, they are telling me to calculate the mass of what? The mass of calcium chloride. Calcium chloride is here. They want me to calculate the mass of calcium chloride when given 40 grams of calcium carbonate. So I'm just going to compare these two, what I'm told to find and what I'm given. So I'm just going to compare this one and this one that is there. So these questions that look like this, you discover that these ones are already balanced. These equations are already balanced. So if you look at this without even wasting much of your time, this is already balanced. Calcium 1, calcium 1. So this is not balanced. So let me balance it. Chloride 2. So let me put a 2 here. So this is not balanced. But most of the equations that do come get to be balanced. So hydrogen 2, hydrogen 2, chlorine 2. Okay, I guess this is now balanced. This is what you are supposed to do. So you just need to look at these questions critically. So this is now balanced. I see, okay, here it was not balanced. So this is now balanced. So these big ones, sometimes they are already balanced. So you just need to pay attention to what a question is requiring. So here, this is the example that I'm going to give. We've covered these things, so I don't want you people to be wasting much time on these things. These are things that we know. These are things that we've been covering, so you just need to know this. So what is the mass for this one? You start doing this. I guess you know this. This one, you are going to get 100. You're going to get 100 grams of calcium carbonate. You are equating to this one. So this one, if you find you do this, what you are going to get will be what? 111 grams. Of what? This is calcium chloride. Of what? Calcium chloride. This is calcium carbonate. Then you are given for calcium carbonate that it is what? 40. So you just put a 40 here, 40 grams. If this one was balanced, I would have multiplied with a number that I'd used to balance. But since there is just a 1 here, so if I multiply 100 by 1, nothing is going to change. Here, I now put x. This is what I need to do. So from here now, the other thing that I'm supposed to consider, what am I going to do here? What I'm going to do here, I say this one times that one. This cancelled. X times 100, I'm going to get 100x, which is equal to what? I multiply here. When I multiply, I say 111 multiplied by 40. This is what I'm doing. I divide both sides by 100. I divide both sides by 100. This cancelled. So x is now equal to what? What is x? You multiply what is on top. When you multiply what is on top, that's when you say divide 100. The answer that you need to get should be 44.4. Then you say grams of what? You are finding grams of what? Calcium chloride. You are done. So this is just a continuation. This is what you are supposed to do. You don't even need to waste time when answering these things. These are simple things, and I want you to just follow me. The same way I'm answering, this is how you are supposed to answer. I'm giving you all these things so that in an exam, you will be able to remember these. So I'm taking my time to explain all these things so that you understand. If you are to meet a question like this one in an exam, you'll be able to answer that particular question. Let us look at a question and another question. So let's say you are given, so I guess you are familiar with this question. I guess you are familiar with this one. Yes, you are. So you should not be watching me. You are supposed to be calculating, lest I make a mistake. I can also make a mistake even as I'm calculating. So let's say you are given a question to say, consider, I guess you are familiar with this one. Consider the reaction below. So consider the what? Consider the reaction below. Consider the reaction below. This is what we are given. So it is already balanced. This one, like this, sometimes they will tell you to say balance. So it just depends, like this, then giving us what? 2 magnesium fluoride, like this, plus uranium, like this. This is what you are given. Then they are telling you to say how many. So this is what they are telling you. How many tons How many tons? Some of you can even be confused. How come tons? How many tons of uranium? How many tons of uranium can be produced? Even as I'm writing down, you're also writing down. I've been telling you that these things you're supposed to be writing them down. How many tons of uranium can be produced in the above, in the what? In the above reaction, in the above reaction using, so say using 24 tons, using 24 tons of magnesium. So using 24 tons of what? Magnesium. This is a question that is given here. You ask yourself, okay, I'm given tons, this is mass, and I'm told to find the mass. How then am I supposed to calculate this particular question? So what they want me to find is that they want me to find the tons of uranium. Have you seen the tons of uranium when given the 24 tons of magnesium? This is what I'm going to do. So I'm just comparing these two. So magnesium is here. What is the mass for magnesium? Mass number for magnesium. So mass number, that is 24. So when we say mass, we just say grams. So mass, molar mass, and the mass number, these, we are just talking about the same number. The difference is with the units. So when I say molar mass, formula mass, relative, you can find relative, so formula mass, relative molecular, they will say molecular mass, which is Mr. is just one and the same. You can also find words like what is the mass number. So we are, for example, if we get magnesium in question, what is the molar mass for magnesium? 24 grams per mole. What is the formula mass for magnesium? Formula mass, mass. So it is just 24 grams. What is the relative formula mass? It is just 24. What is, so relative formula mass or relative molecular mass, it is just one and the same. What is the mass number? Mass number is 24. So we are talking about one thing, but we are just changing the units. This is what I just want you to understand. So what we are saying is magnesium is here. We are comparing magnesium and uranium. Magnesium 24, because of the 2 that is there. So we are going to say 24 times 2, we are going to get 48. 48 grams. Then we say, we equate to what? To what we want to find. The uranium that is there. Uranium, there is no number there. So what is the mass number on the periodic table for uranium? That is 238. So 238 what? Grams. Of what? Of uranium, this one. Then I say magnesium, I'm given what? I'm given 24 tons. So I put my 24 there. I say 24 what? 24 tons. There is no need of converting. Just answer according to what you're given. You put X there. This is what you're going to do. So you know that this one is going to be multiplied by that one. Somewhere you are going to divide this one by the product of that. Where this gram and that gram will be cancelled, we are just going to remain with tons. So when you just reach here, I advise students. So I'm making this very simple. I always advise students to say, concentrate on the numbers. X times 48. You just say 48x, which is equal to, you just concentrate on the numbers. You know that they want you to find the tons. You know that this and that will be cancelled somewhere. So here when you multiply 24 multiplied by 238, what answer are you going to find? You say, okay, divide 48. Even here, I divide by 48. This and that cancels. Then I'm going to say x is now equal to, if you divide here, when you multiply 24 times 238, After you see the answer on your calculator, divide it by 48. You are getting 119, isn't it? 119 tons. So we say 119 tons of what? Of uranium. You are done. So don't say, Tanzi, we never did something on Tanzi. This is how you are supposed to. I guess you are familiar with this question. You saw it somewhere. So I expected you to do a good job. So this is what you are supposed to do. So this is something that we need to understand. The same way I'm explaining, that's the same way you are supposed to be answering questions in an exam. So there is something I want to introduce here. Since we've covered the mole to mole calculation, mole to mass, we've also done mass to mass. We've covered everything. We've done a good job and we are yet to complete the mole concept. So like the same way you've been understanding, we are just remaining with a simple part, something that is so simple. So I'm here to introduce now something that I'm calling limiting reagent. Don't say, sir, the lesson is too wrong. No, this is something that is so simple. Limiting what? Reagent. We did something like this. So if this is boring to you, then there's something that is not okay with you, because we've just covered something that we did, we were revising through, and these are some things that you are supposed to know. So I just want you to know this. I want you to understand this. This is something that is so good. Chemistry is so good if you understand the concept. So the question that you need to have, what is a limiting reagent? Sometimes they may tell you, what is a limiting reagent? You need to know what a limiting reagent is. So to give you a background on this, let's say we've got this is a pot like this. Have you seen a pot? You put water there. You put water there like this. You want to cook nshima. So you start boiling that water. At some point, this is heat. I just want you to give you a picture of what limiting reagent is. So you are going to fubila like that. Then you want to finish now. Muchibemba we say warambo kunaya. Urefa wambo kunaya. So ngawambo kunaya padia, you discover that you'll be putting milimil. You'll be putting milimil. So if milimil is done without making a product here, a food product here, you discover that we were using what? Water here. We add water there. And we add, this is milimil. This one was what? Milimil. So it was milimil, this one. So milimil, we had to run out of milimil, but water was still there. And shima was not made. Meaning that milimil is the limiting reagent. It has finished before the end of the product that we want to find. So in other words, a limiting reagent is a reagent that is in short supply by the mole ratio. Hence, it finishes before the other reactants are completely reacted. That is a limiting reagent. I guess you understand. You've got so let me write down this definition. So I guess we have a picture of what I'm talking about. So I'm saying that a limiting reagent is a reagent or a reactant. So reagent and reactant, it is just one and the same. When I say limiting reagent or limiting reactant, it is just one and the same. You should not be confused. Because some people can say, we just did limiting reagent. So a reagent and a reactant, they are just the same. So a limiting reagent or a limiting reactant is a reactant that is, is a reactant that is in short supply. That is in what? This is in. That is in short supply. That is in short supply by the mole ratio. By the what? By the mole ratio. By the mole ratio. And hence it finishes, hence it finishes before the other reactant, is completely, is what? Completely reacted. Completely reacted. This is what you need to understand. This is a limiting reagent. So we are saying that it is a reagent that is in short supply by the mole ratio, and hence it finishes before the other reactant is completely reacted. Which word have I used here? Mole ratio. So this is to tell you that whenever you want to determine the limiting reagent, so a limiting reagent determines the extent to which a chemical reaction can proceed and the amount of product that would be formed. And you need to understand that for us to determine the limiting reagent, you need to understand that it is important to identify a limiting reagent. And if we want to identify the limiting reagent, we get to use a balanced chemical equation and the mole ratios of the reactants. So this is an equation like this. I want you to understand what I'm saying. Like this is, we get to produce C, maybe let's say C plus D. So these are the reactants. A limiting reagent can just be A or B. You can't say that this one that is here is the limiting reagent. No, it can't be a limiting reagent. These are the reactants. These are the products. So these are the what? These are the products, the end product. So I'm telling you that for us in identification of the limiting reagent, the balanced equation and the mole ratio of reactants are used. Secondly, which is something that is more important now, you cannot use volume. So I want you to note this one. You cannot, and you never, you cannot use volume, concentration. So you cannot use volume or concentration or masses, or use what? Or masses of the reactants. Of the what? Of the reactants. Of the reactant. Since, so I would say, since these will easily deceive us, they will do what? Easily mislead us. Say they will easily deceive or mislead us. So you cannot use volume, you cannot use concentration, you cannot use masses, but you can use the formula for volume, formula for concentration to determine the number of moles. That's when you are going to predict which one is the limiting reagent. So if you want to calculate the limiting reagent, you need to calculate the mass for the molar mass for A, the molar mass for B. After you calculate for these two, that's when now you can determine the what? The limiting reagent. The one that is going to have less number of moles, that is a limiting reagent. So if you calculate the moles for this one, you calculate the moles for that one, that's when you'll be able to determine a limiting reagent. This is something that you are supposed to know. There is also what we call an excess reagent. So I guess you know how to calculate the moles. Yeah, we've done that. So I'll test you if we can put what we've learned into practice by giving you a question. So you also need to know there is also what we call an excess. There is also what we call an excess reagent. So what is an excess reagent? An excess reagent, this one is just a reactant. So it is a what? It is a reactant that remains. That does what? That remains. So that remains unreacted. So that is a reactant that remains unreacted at the end. So at the end of the reaction. At the end of the what? At the end of the reaction. So you discover that when the other reactant finishes, the reaction won't proceed. The reaction will end. Meaning that there are other things that are going to remain. So you discover that those things that will remain unreacted, while this other one, everything is completely done. That one we get to call it the excess reagent. So these are some things that I want you to know. I guess we are moving together. You are able to understand this. So this is where we are going to end from. I will give you a question. On the one of the questions will be calculate the limiting reagent. I've told you how we calculate limiting reagent. Find the number of moles for A, number of moles for B. So find the number of moles for the reactants, all the reactants that are there. Then the one that will have less number of moles, that is the limiting reagent. So this is something you need to know. This is what you are supposed to get. This is where we end from. And let me see how you are going to answer a wonderful question that I've prepared for you. So I want to see best answers. I want you to get the question, analyze the question very well, then proceed to now answering it. Thank you so much.